Welcome to the Data-Driven Manufacturing Podcast, where we explore how data is transforming the manufacturing world. My name is Rowan Easter Robinson, and I'm an engineer at Track My Machines. I'll be talking in every episode to engineers, business owners, and professors who are leading the way in data-driven manufacturing. Let's get started. So today I'm here with Andrew Sherlock, the Director of Data-Driven Manufacturing, and we're here at NMIS, aren't we, Andrew?
We are, NMIS, National Manufacturing Institute of Scotland.
Yeah, absolutely. So NMIS has been running here for quite a while now.
So we moved into this new building June of last year. NMIS itself has been around for 3 or 4 years before that, and prior to that the Advanced Forming Research Centre, which I think is 14 or 15 years old.
Yes, that's been going for a while as well now. And so as part of, you work a bit for NMIS and a bit you've got lots of different jobs as well. What do you do day to day here at NMIS and in your other jobs, Andrew?
Yeah, so I'm, like you said, I'm Director of Data-Driven Manufacturing at NMIS, which means I kind of lead on all aspects of data science, artificial intelligence, machine learning across the NMIS group. And trying to look at ways that we can be making use of some of these new technologies in a manufacturing context to help manufacturers across Scotland and the UK become more competitive, productive, help them meet their sustainability goals, net zero and all of that kind of thing.
Yeah, exactly. And we're here for an event today, which we'll talk about a little bit later why we're here, which is one of the projects you're working on here at NMIS, which is trying to help manufacturers be more productive.
Yeah.
And it's funny how NMIS obviously is focused on Scotland and also on the Glasgow city region you mentioned as well. The Glasgow region. But we've had people arrive from all over. I've come from Sheffield. We've had people from Cambridge, University of Cambridge as well. We've had people from all over.
People coming down from Inverness today as well, I think.
Which is also a long way north, you know. So yeah, we've had lots of manufacturers from all over the UK. So this has quite a big impact. What happens here at NMIS around the UK. Okay, so tell me more about what you do day to day, as well as being at NMIS. You work with kind of manufacturers in a commercial context as well. You run a business.
Yeah, I sort of have a foot in both camps, both commercially and obviously in this environment here. So half my time roughly I got this role at NMIS. The other half of my time I run a company called ShapeSpace, which is a spin out from the University of Edinburgh. So they're kind of related. They're both about effective use of data in an engineering and manufacturing context. ShapeSpace, we span out of Edinburgh University with some technology to look at 3D models of components and allow you to do search by shape. So where you don't know what something's called, but you do know what shape it is, we'd help people to find similar components. We now license that to a number of other CAD software vendors and work with other CAD developers on cutting edge geometry and machine learning applications in manufacturing.
Yeah, and I guess that means there's probably some CAD software that people listening to this might be using that uses your software.
Potentially, yeah.
Maybe a little bit. Depends if they're kind of like a big aerospace manufacturer or automotive, or if they're more of an SME.
The end users are typically using product lifecycle management software, PLM software in aerospace, automotive organizations.
Yeah, so they need to really manage and track what's happening to their CAD models, because those are their IP, I guess. Yeah. That's the most important asset.
And it's interesting that I think, a large, say, automotive company may have millions and millions of 3D models of the components, and nobody has a really good, solid overview of all of those. So you typically find lots of duplication. So where you've got the same part with different part numbers for historic reasons, or you've got lots of parts with similar function but slightly differing geometry. And over the years, we've done quite a lot of projects with large manufacturers to help them understand where there's duplication in their parts libraries, where there's groups of similar components, where they're perhaps paying a big price differential for two very similar components, and not know about it.
Because they were quoted once and then quoted again.
Quote wait, and exactly. You just carry on paying what you've always paid.
There's a lot of waste, there's a lot of hidden waste.
A lot of hidden waste in there, and if you have the right tool sets, you can go after those kinds of problems and find them, because you probably have the data. What you don't have is the knowledge. Yeah,
and that's what this podcast is all about, is finding the hidden waste, trying to use technology all across the workshop and the manufacturing process. So fascinating. And just talk little bit more about the finding a model based on its shape.
Yeah.
We talked earlier off the podcast a little bit about I mentioned the word semantic search. It's kind of something in code and programming. It's trying to find something. You're searching on something based on its meaning and its representation rather than just its file name. It's the words that it uses. You're looking at the actual underlying meaning of that thing. So you don't want to know, you can imagine a CAD file name might be bike part 006 V2 V3 draft sent from, I don't know, supplier. So that file name means absolutely nothing. But the model is valuable, really valuable information.
And you may try and add attributes to a file or a model within wherever you're storing that, but there's more information in that file than is in the attributes.
Yeah.
So that kind of content-based search, so looking at the content, which in our case is a 3D model, maybe an assembly, in which case there's a lot of information in there, and then being able to use that to reason about it and solve business problems at the end of the day.
Yeah.
I think it's kind of an interesting and key thing that we work on. How do you get into the geometry and properly understand it?
Yeah, and you mentioned talking about database indexes to make it easy to search for whether things are colliding inside assemblies.
Yeah, so we've more recently been working on kind of evolved, if you like. So we were working on some projects where what we were interested in is how parts are changing through the design phases of a complex product like a car or an aircraft. So you might look at a model and say, the last modified date is changing all the time, but only at certain periods will the geometry change significantly. And when that happens, there's often sort of downstream processes that need to know. You maybe need to update your finite element models, or you need to speak to someone in manufacturing to work out that you're going to be able to make that component. And so we've been building some new algorithms which are about, if you like, following horizontally the components through a large program and picking out when interesting things are happening, and then telling people about that in appropriate ways. Of course, so that's single components changing, but they live in the context of an assembly or a product overall. So if you make that change, are you going to cause a clash? Are there things nearby that need to be aware of that change that's just been made? So we've been working, as well as having that kind of spatial index over the CAD models and the program, we've also got this, the geometric index, we've also got the spatial index, so we know what's near everything, and we can very efficiently run queries to find that sort of stuff.
Yeah.
Now, why you want to use that might depend on your application, but that's kind of some of the stuff we've worked on.
If you've got 1,000 engineers working on design of a car, you need to know if things are colliding and you can't assemble it.
Exactly, and it's very hard for anybody to fully understand the status. You know, where are we? Which parts of this design are mature? Which parts of them are not mature yet? If we make a change here, what impacts is that going to make? And obviously that depends. You know, early on in the project, you may be quite happy with a lot of uncertainty, a lot of change happening. Later on in the project, you don't want to change some critical components.
It costs a lot to change late in the life cycle.
It costs a lot, and you may have unexpected consequences of that. So fundamentally, we're about trying to build some geometric solutions that allow you to kind of get that view of what's happening. And like you say, it's you kind of have the data, but you don't necessarily have the visibility of it.
No, exactly. Thank you. Enough. So that's ShapeSpace. Enough about 3D models. It's a fascinating topic. We probably spend all day talking about that.
Yeah.
Let's talk about the projects here at NMIS that you're working on. There's a few that are directly, hopefully, helping SMEs in the Glasgow area and also wider in Scotland and hopefully the UK. What are those projects?
So the main project we're working on at the moment is called the Data-Driven Design and Manufacturing CoLab, D3M CoLab. And that, it kind of follows on from the story from ShapeSpace in some ways. So over the years, we've done lots of analytics projects for companies. And I've probably done about 30 of those over the years. And having done those, it sort of becomes obvious that it's quite hard just to parachute in a bunch of data experts into a manufacturing organization and extract value from that. The manufacturers, in my mind, have manufacturing problems. You know, how do we get the yield higher on this product? How do we remove this waste? How do we make more profit out of our product line? Those kinds of questions. they're about manufacturing. At the other end, you have data scientists who may be like really good at machine learning, but maybe don't have the understanding of the manufacturing processes. And I found that you have this kind of communication gap, that it's hard for both sides to talk to each other. And so it's my view that what we should be doing is creating within manufacturers a kind of cohort of people who, they don't have to be world experts in the latest cutting edge large language models or whatever's trendy at the moment, but they need to be significantly more data competent than just being good at Excel.
Absolutely, yeah.
And those are the people who can span the gap, so they can understand the manufacturing problem, think about what data is available that might solve that problem, think about what the algorithmic approach might be to solving it, and then if necessary, go in having conversations with the real experts, but doing it in an educated fashion. So in a nutshell, that's what the D3M CoLab is about, is how do we build that kind of cohort of people who are competent in data but embedded in companies.
Yeah.
So we piloted this, and then we got some more significant funding to do this within the Glasgow city region. I think currently we've had about 160 people go through that in about 65 companies. So this was funded by Innovate UK as part of the Glasgow Innovation Accelerator. What we do is we go into the companies, we talk about the problems that they might have, what kind of projects they could do that would solve those problems, what people they have that could do those projects, but what skills don't they have? You know, probably bright people in there, competent engineers that can do their
really
day
good
job.
CAD programmers, really good operators,
yeah,
really good
exactly.
process optimization people.
Exactly, they've maybe
they might have maxed out where they could be,
and they've maybe fiddled at home with a Arduino
Raspberry Pi
or Raspberry Pi. You know, that kind of person. I think most organizations have people like that.
Yeah.
But they probably lack some key skills. So we go in, do what we call a Kickstarter, think about what the project we might want to do, what people, what skills can we have. So we've now got a portfolio of about 5 different courses: data science in manufacturing course, an AI for manufacturing course, 2 or 3 online courses, and we collaborate with people like the Data Lab and the Smart Manufacturing Data Hub to build that portfolio of courses. And what we expect people to do then is, when we do the assignment as part of the course, it's based on the project. It's based on real data coming from their organization, trying to solve a real problem. So they'll do that as part of their assignment, but we don't, at the end of the course, we don't give a certificate and wave them goodbye. We essentially say, well, carry on now. You carry on doing that in your organization.
You're solving a real problem, or you're halfway through.
You're halfway through, you need to get that to being deployed. You've done it once, you probably need to do it every week, or build a dashboard, or write a script, or, you know, build an application that will solve this problem in the long term. And that's obviously often quite a difficult thing to do. So we're here then to provide the hand-holding.
Yeah.
We call that the Sidekick project, which is the running that through from
to production.
And
that's, for me, I went to a data science show or an event in Sheffield at Cutler's Hall. That was about data manufacturing again, and they talked about there's kind of a dilemma or a trilemma. SME has to, for new technology, you buy off the shelf, you contract it, but you do it in-house.
Yeah.
You're teaching them to do it in-house, which is, in theory, that's kind of one of the best options.
Yeah, okay, so I think it's interesting, that whole question, because I think sometimes the economics of writing software. So if I take my NMIS hat and put my ShapeSpace hat on, you write, software's expensive to write.
And to maintain it,
and,
just as expensive,
you know,
it could be.
So you want to write it once and sell it 1 million times, because the cost of distribution is really low. So I think you end up with a software industry that's very interested in that kind of dynamic. But in manufacturing and engineering, there's quite a diversity of a range of needs. Each sector's different, each product's different, exactly what you need is different. So you end up with these models where you're trying to get 80% out of the box and then 20% customization.
Yeah, exactly. And that customization might cost as much as the out-the-box license.
Yeah, but it's in the software company's interest to downplay that a little bit.
To get it the license in.
Because they want to sell the software.
Can you just do this?
Exactly.
Yeah,
so,
it'll cost you 10K.
So I mean, so you do get successful implementations of PLM and ERP and so on, but there's also the horror stories where it's not gone so well. So you've got that kind of approach. Consultants can come in, and you can parachute consultants in, but they go away, don't leave you any capability behind.
Yeah. A bit like with the initial project that you work with.
Yeah, the kind of stuff I've done 30 times. We come in, we make a difference for a bit, we go away, and you go back a year later and you find that most things have settled back to the way they used to be.
Yeah.
And so I don't have a good answer, but I think it's a difficult question for manufacturers to answer, because at the end of the day, you make whatever your product is. You're experts in making...
You're experts in machining.
Your widget or your, widget A or widget B.
Not in software engineering.
Not in software engineering and not in data. So it's a difficult question to answer. So part of the CoLab is about having some people in your organizations who are then an educated customer.
And they can pick the right software solution, ask the right questions.
So if there is an off-the-shelf solution, or if there's a customizable solution available to you, then fantastic. That's the easiest way to go and get something. It's going to be supportable, it's deployable in the long run, but do it in an educated way rather than, taking a punt on something.
Exactly. And that's what I mean. At TMM, I focused on CNC machine shops, and that's it.
Yeah.
I want to be the best product for them.
Yeah.
That's because they're a niche. Most of them want very, very similar things. When they see their shift patterns, how the machines are running over shifts. They want to see the setup times, the cycle times, changeover times. Really, really simple. And so if you can, but there's not, I think TMM fits in a slot where a lot of big software companies just don't want to do that.
Yes.
There's kind of low-hanging fruit, which is we can install any machine tool, really easy to install, 45 machine a month, free hardware. And that's low-hanging fruit, but no one's picked it.
Yeah. And I would guess it's not the entire thing that any of your customers want to do. There's always some stuff around that, but you found that sweet spot, 80% of what you want to do, we can do this way, and there's enough customers there for you to build a sustainable business on the back of that.
Yeah, because they've got ERP systems, they work really well, but they don't do machine monitoring.
Yeah.
I'm not going to build an ERP system. I know how hard that is. Well, I don't. I can only guess how hard that is.
Yeah.
So I want to do machine monitoring and do it well, and then integrate with ERP. That's the beauty of software.
And there's an interesting thing in this, I think, is one of the key inhibitors to deployment of some of these technologies is that fog of just not knowing. You probably think there's a solution out there.
Yeah. Finding it is the hardest thing.
It is, but how do we not make some bad decisions in this?
Yeah, people get burnt.
And you can get burnt, so it's easier sometimes not to make a decision than to fight through that. So partly the idea with the CoLab is we're not being prescriptive about any particular solution. It's more about getting people so they feel more and more comfortable about using some of these technologies and then applying them and trying it out with a degree of support around them.
Yeah.
So you're not on your own. If it doesn't work, because with the best will in the world, sometimes things just, you can't get the syntax right, or you don't quite understand how to connect this to this. Well, we can provide that kind of support.
Exactly. So you're not alone with software engineering, with the CoLab project here at NMIS, driven by Andy. Thank you very much, Andy Sherlock. And we've almost covered all the topics. We've been talking a lot, so we need to wrap up almost. Yep. We're here today at NMIS for it's data in manufacturing day. What's the day called today?
So
I think it's data in manufacturing.
If I kind of explain, this is a kind of continuation of that whole D3M CoLab idea. So there's a smart manufacturing data hub, which is a large UK-wide, Innovate UK funded project, basically to encourage the use of smart manufacturing technologies in manufacturing across the UK. We've been working them on a lighthouse, as they call it, particularly focused on machining as a sector. So my colleague Connor McFadden has been working on this. He's the machining lead here at NMIS. And what we're trying to do is take that idea of CoLab and apply it to companies that are doing machining probably aren't currently getting data off those machines but would like to. So taking that same approach, sitting down them, where are you currently, what you're trying to achieve, let us put some courses on, and we're working on some demonstrators out in our digital factory downstairs where you can come in and see some off-the-shelf solutions for getting data off machines, some more home-brewed versions, where that data goes, where we're going to store it, how you might analyze it, and so on. So it's the same kind of idea as the more general CoLab, but focused in on machining.
Yeah, absolutely. We've had some CNC machine shops come in today. We also had some metal recyclers who are interested in hooking up metal blasters and metal washers. So we'll see what happens there. But yeah, people came from all over the UK to find out how they can hook up their machinery and what the most cost-effective solution might be.
Yeah, and help them get through that fog of indecision, if you like, to understand better what it is that, what the solutions out there, how do we choose which ones are the most appropriate solutions. And hopefully, ultimately get something in and deployed and making a difference to productivity, net zero.
Yeah, these are all linked.
Competitiveness, like we said at the start.
Yeah, absolutely. And trying to improve all of those things for your business is all linked around adopting new technology and new ways of working, new ways of manufacturing. And just a quick question, Andy. Thank you so much. We've covered all of our topics today. But I'd like to know your opinion, if you can, on at TMM. It seems like the customers seem to be early adopters. The people who have taken on TrackMan machines and machine monitoring generally are interested in pushing the machine shops forward, and they seem to be people who are interested in technology for its own benefit, but they like the tech as well. They're adopters. They might have a flip phone or whatever. They might not a flip phone, a folding phone. They might have some piece of tech that's new, like your folding phone.
Gadget person,
Exactly. They might also be a bit gadget people. And I don't know. I can't predict, and I don't really want to. How long do you think it'll take before the kind of technology we've seen today, from like the likes of Sandvik, from other companies, from TrackMan machines? How long before we'll go from early adopters to the kind of the main adoption curve, where most manufacturers you go in today will have some form of machine monitoring and insight into how the machines are running?
I don't really know. I find it interesting the kind of profile of people that we're seeing in the CoLab. I think a lot of organizations do have somebody who is the organization as a whole might not be an early adopter, but there are people whose aptitude within those organizations are interested in new technologies, what might we do in 4 or 5 years' time. So there's a bit of, sometimes you need the pioneers in your organization who are going to at least get involved in the kind of things we're doing and then become the champion for it in their organizations. I think it's sometimes difficult to know exactly how long some of these technologies take to mature and actually get fully adopted. We were having a conversation earlier about CAD and the cloud with one of the partners that was here earlier, and it was kind of interesting that some of this stuff has been around now for 10, 12 years, and it's just about starting to get...
Takes a long time for this technology to become...
So I think sometimes it takes longer than you think. Then after 10 years you look and think, oh wow, we've come a long way.
Yeah, because these are gradual steps.
The gradual steps, and it's all sort of slow, but ultimately, when you look back 10 years, you've come a long way.
Brilliant. Perfect. I think that's everything, Andrew.
Cool.
Thank you so much for your time.
Thanks you for coming along, and thanks for doing this.
Yeah, brilliant. So thanks for being a guest on the podcast today, Andrew Sherlock. You're director here at Data-Driven Manufacturing at NMIS, amongst other things, business owner at ShapeSpace. Yeah. That's been the Hidden Waste in Manufacturing podcast, where we're trying to help you find out what's happening in your machine shop, all those hidden things that are costing you time, money, maybe even operator health, all these things that are really important to your business, but you cannot see with your eyes and ears. So thank you very much, Andrew.
Thank you.